Hey guys, so in this video I wanted to go over 3 different examples of what's going to be on your quiz tomorrow. So for the first one, we have x squared minus 11x plus 30. So the first question we always ask is, do we have a greatest common factor? No, we do not. So we put none or no or whatever you want to put, showing that there is none. Then we want to factor it. So because our a is understood 1, we can go ahead and do our big X method. Well, our b is negative 11, which comes to the left, and our c is 30. So that is going off to our right. And then we're going to ask ourselves, what times what gives us 30, but also adds and subtracts to give us 11. So we can create a t-table, and we can start with 1. Well, 1 times what gives you 30? 30. But we can't add and subtract 1 and 30 to get to 11, so we have to keep going. Next number you should try is 2. Well, 2 can go into 30 evenly, because you can do 2 times 15. 3 can go into 30, 3 times 10. 4 cannot go into 30 evenly. If you do 30 divided by 4, it gives you a fraction, so you don't include it. So then you go to 5. 5 can go into 30 evenly. It's 5 and 6. So now, is there any pair of numbers that you can add or subtract to get to 11? Yes, 5 and 6. So 5 and 6 are going to be your magic numbers. Now you need 5 times 6 to give you positive 30, which is true right now. But then you also need 5 plus 6 to give you negative 11. So right now that is not the case. So what if I made 5 negative? That's still not giving me negative 11. So what if I made 6 negative as well? Well, negative 5 plus negative 6 does give me negative 11. So now that is true. Does it make the multiplication true? Negative times a negative is a positive, so yes. So our magic numbers are negative 5 and negative 6. Now in this case, to get our a to equal 1, did we have to slide or divide? No. So on our factored form, we simply have our 2 parentheses, the variable that we were factoring, so x, and our first magic number was negative 5, so we have to subtract 5. Second magic number was negative also, so we have to subtract 6. And that is our factored form. So that is what we were doing in lesson 2. Now, in lesson 2 as well, we have an example like this. 4v squared plus 44v plus 120. Do we have a greatest common factor? So the easiest way to look at this, or easiest way to check to see if we have a greatest common factor, smallest number we were given, or smallest coefficient, was 4. Can 4 go into 44 evenly? Can 4 go into 120 evenly? Yes. So we're going to have to divide all of our terms by that greatest common factor. So that 4 comes out front, and we're going to do 4v squared divided by 4, which gives us v squared. Then 44v divided by 4 gives me positive 11v. And then 120 divided by 4 gives me positive 30. So now that I have factored out my greatest common factor, I'm going to kind of figure out or see if I can factor this parentheses any more than it already is. Well, I think I can. Is my a, or is my coefficient of my variable squared, 1? Yes. So then I can go straight to my big X method. My b is 11, and my c is 30. Can we find 2 numbers that add and subtract to give you 11, but also multiply to give you 30? Yes, we can. So 1 and 30, multiply together to give you 30, but don't add and subtract to give you 11, so you have to keep going. 2 and 15, 3 and 10, 4 can't go into 30 evenly, so we don't include it. 5 and 6. 5 and 6 do add and subtract to give you 11. This one we do not have to change them to become negative because 5 plus 6 is positive 11. Now, in this case, did we have to slide and divide? No, our A was already 1 after we factored out our GCF. So our GCF is already on the outside. So it just stays on the outside for our factored form. So we have 2 parentheses for our factored form. The variable that we were factoring was V. And our magic numbers both were positive, so we have plus 5 and plus 6. And that is our factored form for this example. Now, the third one that I have pulled from our packet comes from lesson 4. Lesson 4, we were factoring like we've done in lesson 1, 2, and 3, but then we have to find our solutions once it's factored. So we're going to look at this and say, okay, does one side equal 0 yet? No. So we're going to subtract 5. From both sides. So then we're going to get 49p squared plus 371p, and then subtract 168 equals 0, because the 5 minus 5 equals 0. So what we want to do is see if there's a greatest common factor. Hopefully, if you see a 49, it's kind of an indication that you should try 7. Can 7 go into 49, 371, and 168 evenly? Yes, it can. So our greatest common factor is 7. So we're going to come in here. We're going to have 7 out front. And we're going to divide all of the terms out by 7. So 49p squared divided by 7 gives you 7p squared. Positive 371p divided by 7 gives you positive 53p. And then you have negative 168 divided by 7, which gives you negative 24. Is there anything else that we can take out, or did we have our greatest common factor too small? Okay, did we have a bigger greatest common factor that we could have chosen? No. So once we are at this point that we have factored our greatest common factor, we want to see if we can factor this parentheses any further than it already is. So is our A equal to 1? No. So we have to slide our A to our C by multiplication. So now we have p squared plus 53p minus 168. Now is our A 1? Is our coefficient of our variable squared 1? Yes, it's right here, as understood. So then we can go to our big X method. Our B is 53. Our C is negative 168. We're going to create a table to see what two numbers or what our magic numbers are. So 1 can go into 168 evenly, but we cannot add and subtract 1 and 168 to get to 53. So we have to keep going. Well, 168 is an even number, so I know 2 can go into it evenly. 2 times 84 gives me 186. But we cannot add and subtract those two numbers to get to 53. So one more. 3 can go into 168 evenly. 3 times 56. And we can add and subtract those two numbers to get to 53. Now, just making sure you can see it. So 3 times 56, and I want negative 168. 3 plus 56, and I want to equal 53. So which one has to be negative? Well, that 53 is positive, so that 3 has to be negative. Negative 3 plus 56, or 56 minus 3, is 53. So that 3 is negative. For the multiplication, negative times a positive is a negative. So that is what we want. So factored wise so far, we get 2 sets of parentheses. The variable we were factoring was p. And we have a negative 3 and a positive 56. But what method were we using? Were we just doing big X method, or were we also sliding and dividing? We were also sliding and dividing. So we have to divide by what we slid. We slid a 7. So we're asking ourselves, can we simplify this 3 over 7? No. So the denominator has to go in front. Can we simplify 56 over 7? Yes, we can simplify it to 8. Now, is 7p minus 3 times p plus 8 our factored form? Or did we have a greatest common factor out front? We had a greatest common factor out front. So our factored form is 7 times our 7p minus 3 times our p plus 8. So that is how we're finding our factored form for this third example. Remember, if I'm going too fast, pause the video and you can keep going once you're ready. So once we have our factored form, we have to find our solutions. I'm going to take one parentheses and do 7p minus 3 equals 0, and p plus 8 equals 0. So I'm solving for my variable, which is p in this case. So plus 3, 7p equals positive 3. P is still not by itself, so I gotta divide by 7, p equals positive 3, 7 for the first parentheses. Second parentheses, p is not by itself, so I need to subtract 8, cancels out, p equals negative 8. So my solutions for this third example is 3 over 7 and negative 8. So please remember, we'll have a few minutes to review tomorrow, and then we'll take our quiz.